laser. The power emitted is 2 into 10 raised to power minus 3 W. First, what is the energy of photon in the light beam? Second, how many photons per second on an average are emitted by a source? Click on the buttons to view its answer. Solution A. Each photon has an energy E equals to h mu, where h is 6.63 into 10 raised to power minus 34 joules per second and mu is 6 into 10 raised to power 14 hertz. Hence, E equals to 3.98 into 10 raised to power minus 19 joules. Second, what is the de Broglie wavelength associated with A. An electron moving with velocity 5.4 into 10 raised to power 6 meter per second and B. A ball of mass 150 gram traveling with speed 30 meter per second. Click on the buttons to view its answer. Third, an electron, an alpha particle and a proton having same kinetic energy, which of these particles have the shortest de Broglie wavelength? Click on the button to view its answer. For a particle, de Broglie wavelength lambda equals to h upon p. Kinetic energy k equals to p square upon 2m. Then lambda equals to h upon under root 2mk. For the same kinetic energy k, the de Broglie wavelength associated with particle is inversely proportional to square root of their masses. A proton 1h1 is 1836 times massive than the electron, and an alpha particle 4he2 is 4 times that of proton. Hence, alpha particle has the shortest de Broglie wavelength. Fourth, what is the de Broglie wavelength associated with an electron accelerated through potential difference of 100 volt? Click on the button to view its answer. Solution. Accelerating potential V equals to 100 volts. The de Broglie wavelength lambda is lambda equals to h upon p equals to 1.227 upon square root of V nanometer. Hence, lambda equals to 1.227 divided by square root 100 nanometer equals to 0.123 nanometer. Solution. Accelerating potential V equals to 100 volts. The de Broglie wavelength lambda is lambda equals to h upon p equals to 1.227 upon square root of V nanometer. Hence, lambda equals to 1.227 divided by square root 100 nanometer equals to 0.123 nanometer.